Hi, time has come to deliver on the promise that I would release a lithography application. And I call it lithography because there is a partial coherence. We have this also in microscopy, but I think of it as lithography because this is where I spent most of my professional life. So here we have something which is a mask, which is the object we will project. And here is the computed intensity. It is only using scalar theory for many reasons. One is because for interactivity, the full simulation is maybe a little bit too heavy to do in real time at the moment. And we have also the illumination pupil, which is the same as the projection pupil, at least they are projected onto each other. What we can do in this application is add, remove, change objects in real time and play with a lot of things. I will do a little demonstration on something which is fairly easy to, or very easy to see. So objects are moved by clicking at the center, rotated when you grab a corner, and when you grab an edge, they can be sized. So, and once you're over the center of the object or over a white area of it, you can type D and they will delete. There is one special object is the grid, which is fairly common in many applications, and you can rotate it. But since we want to play with the resolution limit, there is also a shortcut for divide the size or pitch by 2. So let's go to, this is pitch 4, 8, 16, 32, and with coherent illumination we have passed the resolution limit. Can we still print it? Yes, we know that if we do some fancy stuff, we can add fancy illumination. This is called a dipole. And if we put this dipole in the somewhat right place, we can now see things which we wouldn't otherwise. And we know also that this classical result is insensitive to focus. And so it is insensitive to focus if we place this right. If we don't, then there is, of course, a little focus sensitivity. So we have this classical result, and we won't get as nice results if we just do this simple sigma or whatever it is, 0.7, and it's no longer particularly focus insensitive, as we see here. So these aberration controls are in waves. And you see this one goes to 0.25, which gives you the classical Rayleigh range limit. The others go to 0.5 and produce all sorts of strange results, or maybe not strange, but we usually don't do lithography when we have this much aberrations. You can also see some classical things, like what happens with astigmatism and defocus, or see the classical coma things. If you look at this little spot here, with if I had lowered the resolution, maybe we would see more. But now everything disappeared, so let's make it, yeah, now you clearly see more of the classical coma result. So it does these simple things also, if this is what you're interested in exploring. These controls have some limitations. In a periodic simulation such as this, there is a connection between pupil radius and these 3 values. So suppose we would do this, and now we decide, oh, we want to simulate 4 nanometer. There is a limit on the resolution of the pupil, which is 255 points, so the pupil radius stays at 127. And so the application tells you, oh, the best I can do is 8.6. So if you want to do something else, you will need to have to look at these things. What is the... yeah, now we are back into something we see, and this is a reasonable radius. Well, maybe we can, of course, have a different sampling density per resolution as we choose here. But so if we change these, we have to look whether the program accepted it or not. So if you're interested in this field, you can find the address here. If you just go to my website, you will find a button here, Interactive Litho, and there is a little bit of explanation what the limitations are. Can be worth reading. You see that I write this is only 1024 by 1024 resolution of the image. Of course, this application can do much more than that if we want to define something else. Sorry. And in the future, if there is time, we can change these to phase object and play with spatial light modulators and so on, but no promises right now because there are other things to do. But if you find this useful and find something that you like to give me feedback on, then you're very welcome to do that. Just click here and whatever you like or don't like, I appreciate any response. Thank you very much.